Another example for inverse functions, we're going to look at hyperbola. Alright, so if you think about a hyperbola, would a hyperbola have inverse function? Well, you know, if you think about the shape here, is it a one-to-one function? Well, it's certainly a function if we do the vertical line test. Horizontal line test, you see, only 1 point. So therefore it is going to have an inverse function. Okay, so find the equations of the asymptote. So in order to do this, instead of actually working out the whole function, we are going to work out what the asymptotes are of the original function, and we're going to work out the asymptotes of the inverse through that knowledge. So you'll see when we have it in this form here, yeah, it's okay, you can't tell what the x-intercept is going to be. I mean, it's telling us what the domain is here, all real numbers apart from 4. So there, obviously, the asymptote here is going to be x equals 4, because you cannot substitute in 4 here, because that would return a value of 0. When it's in this form, your hyperbola is in this form, then it's going to be much easier to work out the asymptotes if we just change the form. So what we're going to do is we're just going to divide. Okay, so we're going to write this in a different form. So we've got 2x minus 1 and we're dividing it by 4 minus x. So just to make this a little bit easier, instead of writing 4 minus x, I'm going to write it as minus x plus 4. And then we are dividing into 2x minus 1. Okay, that's what a fraction is. So what I'd suggest, always write the x as then the number in both. Okay, if they're not set up that way, then you just write them that way. So what we do, we start off with 2x, so we do 2x divided by minus x, and that is going to give me minus 2. Okay, so 2x divided by minus x is going to give me minus 2. So whatever we've got up here, you're then going to multiply it by the two terms that we have down here. So we're going to start off firstly doing minus 2 times minus x, and that's going to give me plus 2x. And then we do minus 2 times plus 4, that's going to give me minus 8. Then what I do is I subtract these values. Now, if you've done this correctly, this will always happen. So 2x minus 2x, they'll cancel, you'll have nothing left there. Then we have minus 1 minus 8. So that's minus 1 plus 8. So that's actually going to be 7. So when we do this, the answer that you've got up here, I mean, that's your answer. Okay, that's how many times it divides in. This 7 down here is our remainder. So this is, you know, very similar to just doing normal addition. So if you've got 4 divided in 9, you see, here I've got 2. 4 goes into 9 twice. Remainder 1. So in this case, your answer, you see, is 2 plus your remainder is 1. Well, you write it as 1 divided by 4. Your remainder still got to be divided by your divisor here. So it's the same when we have these hyperbolas and we want to write it out like this. I want to write this as h of x. So you write down your answer, which is minus 2, plus your remainder. But your remainder still got to be divided by what you were dividing by there, which is 4 minus x. Okay, now we've got it in this form here. So once we have it in this form, it's much easier to get the asymptotes. So the vertical asymptote here is going to be x equals 4. Alright, because when you substitute in 4 into this value of x here, you're going to return a value of 0, which is hence undefined. Your horizontal asymptote, now that we have it in this form, is going to be y equals negative 2. Okay, so your vertical asymptote, so remember, this is for h. Okay, this is for h of x. So therefore, we can use this information now to work out what the asymptotes are for the inverse. So your vertical asymptote and your horizontal asymptote for your inverse. Okay, so your vertical asymptote for your inverse and your horizontal asymptote. So you see this is going to be x equals 4 is in your function, so that means that because you swap the x and the y, it's going to become y equals 4. So your horizontal asymptote is going to be y equals 4. On our function, we have y equals -2. So in the inverse, it's going to be x equals -2. And then that will be what your vertical and your horizontal asymptotes are. Alright. Okay, so now we actually want to find out what the inverse is. So there's two ways of doing this. We can use either version here actually. So when we did example 3 before and we had the parabola, we had to put that into turning point form, otherwise it would be impossible to do. This one is going to have more than one y, but you can actually, it does work out. Okay, now I'll show you both ways. So let's use both of these. Okay, so let's see, we've got h of x here. So in this form it was 2x minus 1 over 4 minus x. And then when we changed the form, we got, what did we get? Minus 2 plus 7 over 4 minus x. Okay, so I just check. Yes, I've got that right. Okay, so when you're working out the inverse, we can do it either way. So I'll show you both ways here, right? So first of all, I'm going to swap the x and the y around. So then we write it with this. Okay, so now what I would do here, I want to get all the y's on top. So what I'm going to do in this case is I'm going to then multiply both sides by 4 minus y. So this is going to become x times 4 minus y equals 2y minus 1. What I then need to do is I need to expand this bracket. So this is going to be 4x minus xy equals 2y minus 1. So I'm trying to find out what y is. So basically I want all the y's on one side. So what I'm going to do is I'm going to take this over to the right hand side. So it'll become 2y plus xy. So therefore I'm going to move this minus 1 over here. So it'll be 4x plus 1. So if you do it a different way, you'll just have different signs. It'll still be the same function. It's all good. So now what you can do here is you see we have a common factor. So I can take out a common factor of y, and then this is going to be x plus 2 in the bracket. It's 4x plus 1. So then y is going to equal 4x plus 1, and we're going to divide both sides by x plus 2. And that will be what your inverse function is, okay, in that form. So again, we can tell what the asymptote is going to be. The vertical asymptote is going to be x equals -2, which, yes, is correct. Alright, now I'll show you this way as well, so whichever way you prefer. We can do this now, so we can go x equals -2 plus 7 over 4 minus y. I prefer the second way, I think it's less work. So what I can do here is, we got 7, 4 minus y, and I am going to add 2 to both sides, so that's x plus 2. Then, what you can do simply here is you can cross multiply. So the 4 minus y and the x plus 2, they swap places. So you're going to have 4 minus y up here equals to 7 over x plus 2. Okay. Now what I can do here is I can add y over here. So you've got y, and then take away the 7 over x plus 2. And either of these is acceptable. As I say, I've just shown you both ways that you don't have to rearrange it, but I certainly prefer the second way here, because if you have to get the asymptotes, but it's entirely up to yourself. Alright, so to write out your answer here, again, you can use either way. So the inverse is going to be h of -1. So if we think about what our domain was for this function here now, if we think about our domain and range table here, So what would the domain be of our original function here? So the domain of our original function, you see, would be what's given in the question, all real numbers apart from 4. Okay, so therefore we know that that is going to be also the range of our inverse function. The range of our function here was all real numbers apart from -2. So therefore that will be the domain of our inverse function. Okay. So when we're writing down our inverse function, we can write what the domain is here. So it's all real numbers except for -2, mapping into a range. And I am going to just choose the second way of writing it. Alright, but you just understand that either way is acceptable. So, the last question here was to find out the point of intersection. So the point of intersection, remember, you're going to do h of x equals h of -1x, but that's not the clever way of doing it. Remember, the clever way of doing it is to do the original function equal to x. That's going to be a lot less work. Okay, so when we're finding out the point of intersection, which is this, always make the original function equal x, or if you wish, you can make the inverse function equal x. So what I'm going to do is just pick the original function here, okay? So 2x minus 1 over 4 minus x. And I'm going to make that equal to x. Okay, so again, you can use any form that you want. You could use it in the hyperbola form that you're used to. I'm just going to use this form. So to solve this, I am going to times both sides by 4 minus x. So it's x, 4 minus x here, you see. And then I'm going to expand this bracket on the right hand side. Okay, which you can do in the first step if you wish, if you're confident. So I get 4x minus x squared. I'm now going to take the two terms from the right hand side over to the left. Okay, so I'm going to add x squared. So it's going to be like this. I'm then going to take away 4x. So this will become 2x minus 4x. And then I've still got my minus 1 here. Okay, so when we're doing this, we now need to factorize. So have a quick scan, see if you can use the cross method. Because it's a minus 1 here, it's not going to be possible. So what we have to do then is either complete the square or use the quadratic formula. So I'm just going to complete the square here because it is nice numbers. So if we do x squared minus 2x, if I half the coefficient of x minus 2, that's minus 1, you square it and add it on. I then take that away. And then I've got this minus 1 is this minus 1. Okay, so tidying this up, writing in turning point form, I've got x minus 1 squared minus 2 equals 0. So continuing, x minus 1 squared, I'm going to add 2 to both sides, it's going to equal 2. X minus 1 is going to be plus or minus the square root of 2. And x, and then I'm going to add on 1. So it's 1 plus or minus root 2. Okay. So, in the previous example, when we had the parabola, there's only one point of intersection, but in this case here, we're actually going to have 2. Because if you look at the domains of your function, okay, there's only like 4 and minus 2 where the functions don't exist. So unless your intersection appears in one of these values, 4 or -2, then they're both going to be solutions. So in this case, your point of intersection between the parabolas here is going to be 1 plus root 2. And remember, because they always meet in the line y equals x, then whatever x value you get, the y value is going to be the same. So they're going to intersect at 1 plus root 2, 1 plus root 2, and they're also going to intersect at 1 minus root 2, 1 minus root 2.